Welcome. This is the review of your homework from last night. I'm going to go through each problem just in case you had any questions before you start your quiz. So, if you look at number 1 and number 2, basically what you have to do here is you have to distribute to get rid of your parentheses. So, in the first one, I'm going to distribute 5 root 5 to both terms, and that's going to become 5 root 50 plus 5 root 5 times root 2 is 5 root 10. Remember, when you're multiplying, inside goes with inside, outside goes with outside. Now, 5 root 10 cannot be simplified, but the square root of 50 can be broken up as root 25 and root 2. So this becomes a 5, and then those two outside terms go together, and this becomes 25 root 2 plus 5 root 10. Okay? In number 2, we're going to distribute the 4 root 15 to both terms. Now, 4 and 3 are outside, so that would become 12 root 15 plus 4 root 15 times root 6 is 4 root 90. Now, 12 root 15 cannot be simplified, but the square root of 90 does have a perfect square. It's 9 and 10. The square root of 9 is 3, and then you put your outside terms together. So that becomes 12 root 10, and your first term stayed 12 root 15. Okay. In 3 and 4, this is where you have to distribute or FOIL to get rid of both sets of parentheses. So in 3, what I'm doing is I'm actually distributing 2 root 5 to both terms, and I'm distributing root 3 to both terms. So when I do that, I'm actually going to have 4 terms that I'm going to try to bring together. So 2 root 5 times negative 2 root 5 is negative 4 root 25. 2 root 5 times 3 root 3 is 6 root 15. Then I'm going to move over to the root 3. Root 3 times negative 2 root 5 is negative 2 root 15. And root 3 times 3 root 3 is 3 root 9. Now, square root of 25 is a perfect square, so this just becomes 5, and this is negative 20. And 3 root 9 is a perfect square, so this just becomes 3, so this becomes plus 9. So your like terms are negative 20 and 9, so that's negative 11. And then you put your radicals together as well, because they're like terms. And 6 root 15 and negative 2 root 15 is 4 root 15. Okay? In 4, we are distributing root 3 to both terms and 1 to both terms. So root 3 times 3 root 3 is 3 root 9. And root 3 times negative 1 is negative root 3. 1 times 3 root 3 is 3 root 3. And 1 times negative 1 is negative 1. Now the square root of 9 is actually just 3. So 3 times 3 is 9. And 9 and negative 1 go together to give you 8. And negative 1 root 3 and positive 3 root 3 give you 2 root 3. Now the last of our operations with just radicals here has to do with getting rid of a radical in your denominator, but there's a binomial on the bottom. When that's the case, you need what's called the conjugate. The conjugate is just the opposite sign in the middle of the binomial. So the conjugate of 2 minus root 3 is 2 plus root 3. So on top and bottom, I'm going to do my distributing. On top, 5 times 2 plus root 3 becomes 10 plus 5 root 3. On your denominator, you're going to distribute the 2 and negative root 3 to both terms. 2 times 2 is 4. 2 times root 3 is 2 root 3. Negative root 3 times 2 is negative 2 root 3. And negative root 3 times root 3 is negative root 9. The square root of 9 is actually 3. And these two middle terms cancel. And 4 minus 3 is 1. So you can leave your answer as 10 plus 5 root 3 over 1. Or you could just write it as 10 plus 5 root 3. That's up to you. Now our next example is 2 over 2 plus root 5. The conjugate of 2 plus root 5 is 2 minus root 5. So you would do that on top and bottom. So you would distribute on top. 2 goes to both terms. So this becomes 4 minus 2 root 5 on top. On the bottom, again, you do your distributing. 2 times 2 is 4. 2 times negative root 5 is 2, negative 2 root 5. Root 5 times 2 is 2 root 5. And root 5 times negative root 5 is negative root 25. So these two middle cancel out. Square root of 25 is 5, and 4 minus 5 is negative 1. So this is 4 minus 2 root 5 on top, and then negative 1 on the bottom. You can distribute the negative 1 or leave it like this. So these are two possible answers you could write for that case. Now, in 7, 8, and 9, our goal is to solve these equations. Now remember, in radical equations, you can have an extraneous solution even if you do everything right. So you must check your answers to make sure that they work in the original problem. Now, the first step in all these is to get the radical by itself. So in 7, I'm going to subtract 3, and this is going to become 2 equals the square root of 12 minus v. To get rid of the radical, you square both sides. So this becomes 4 equals 12 minus v. And then you would subtract 12 from the other side. And this would give you negative 8 equals negative v. So 8 equals v. Now I do have to make sure that works. So what you do is you plug in 3 plus square root of 12 minus 8. And that does equal 5. So this answer does work. Now in 8, the radical is already by itself, so I'm going to start just by squaring both sides. So n squared equals 8 plus 2n. Because it's n squared, that tells me it's a factoring problem. So what I'm going to do is I'm going to subtract 2n and 8 over. So this becomes n squared minus 2n minus 8 equals 0. So I need to find the factors of negative 8 that add to negative 2. And they are negative 4 and 2. So this is n minus 4 and n plus 2. Set those equal to 0. I'd get n equals 4 and n equals negative 2. So those are what I think the two answers are. But if I plug in 4, square root of 16 does equal 4, so that works. If I plug in negative 2, 8 plus 2 times negative 2, the square root of 4. Square root of 4 is 2, not negative 2. So that answer is out. And the only answer I have is 4. So that's the only one you would write as your final answer there. Okay. One more solving would be in number 9. You would square both sides. So this becomes x squared equals negative 100 plus 20x. You bring these terms over. So x squared minus 20x plus 100 equals 0. And I'm looking for the factors of 100 that add to negative 20. So they are negative 10 and negative 10. So it's x minus 10 and x minus 10. So they both give me the same answer of x equals 10. So if it works, that's my answer. If it doesn't, it would be no solution. In this case, when I plug in x as 10, it'd be negative 100 plus 200, which is 100, and the square root of 100 is 10, so it does work. My answer is x equals 10. Okay. Then the last 4 problems have to do with the Pythagorean theorem. So the Pythagorean theorem is a squared plus b squared equals c squared. So in our first case here, they give us a, and they give us b, so we're finding c. So this would be 3 root 2 squared plus 6 squared equals c squared. 3 root 2 squared means 3 root 2 times 3 root 2, which is 9 root 4. Square root of 4 is 2, so that would be 18. And you can do that on your calculator as well, but 3 root 2 squared would be 18. 6 squared is 36, and that equals c squared. 18 plus 36 is 54, so 54 equals c squared. Then you take the square root of each side. The square root of 54 can be split up as 9 and 6. And the square root of 9 is 3. So that's 3 root 6 as our final answer there. Now, in 11, they just want to know, does this form a right triangle? Now, the first thing I have to know is which side is C. So 2 root 41 is about 12.8. So that is actually the largest side. So this would be 8 squared plus 10 squared equals 2 root 41 squared. 8 squared is 64. 10 squared is 100. And 2 root 41 squared would be 4 times 41, which would be 164. So 64 plus does work, so the answer is yes, that is a right triangle. Now in 12, we have to find the 2 missing sides in this case. So they tell us the legs are x and x plus 3, and the hypotenuse is 15. So this would be x squared plus x plus 3 squared equals 15 squared. X squared is easy, it's just x squared. Unfortunately, x plus 3 squared is x plus 3 times x plus 3. So that would be x squared plus 3x plus 3x plus 9 equals 225. You'd bring your like terms together, and this would become 2x squared plus 6x minus 216 equals 0. Now, we take out our GCF of 2, and this becomes x squared plus 3x minus 108 equals 0. The factors of negative 108 that add to 3 are 12 and negative 9. So this would be x plus 12 and x minus 9. So x equals negative 12 or x equals 9. Negative 12 does not make any sense because you cannot have a side length that is a negative. Because x is 9, one side length would be 9 because x is 9. The other side length would be 9 plus 3, which is 12, and the other side length is 15. Okay? And then our last problem you had was a rectangle. On the rectangle, the width was 4, and the diagonal was 5. Hey, look at that, it made a triangle. Okay? And they want to know the length. Well, a squared plus 4 squared equals 5 squared, because 5 had to be your hypotenuse. So a squared plus 16 equals 25. Subtract 16. A squared equals 9. Take the square root of both sides. A equals 3. So your missing side length there is 3. Take your time on your quiz, be careful about your signs, and make sure you check for extraneous solutions when you are solving the equations. Good luck.